Hi, my name is Blake Sheets. Today I'd like to discuss VLSM and CIDR with you and how they interact with one another. Let's start with the lesser of the two and go to the VLSM. Good secret to keep in mind when dealing with VLSM and CIDR is it's always difficult to determine where the dividing line is. Where does VLSM start? Where does CIDR end? Good rule of thumb, go with the dot. Okay, go to the classful, find the dot. If you're working to the right of the dot, you're working VLSM. If you're working to the left of the dot, you're working CIDR, okay? So, starting with VLSM, I'd like to work an example here that would be typical of a high school or any school corporation that you might be working with, okay? I've written some numbers down here, and that these are what are going to be allocated to each of the various school buildings that we need to manage. So, I've indicated we have 100 computers that are in our middle school, or there will be 100 printers, whatever you have in there. We have 50 working out of our elementary schools. We have 20 for our administrators, and we need 6 interlinks to keep everybody connected and talking to one another, okay? So, if we start out with a Class C network, take 00. Standard easy one to work with, okay? This will not fulfill our requirements, but it's a good start. So we'll work the VLSM side with our base network, and we'll go up as far as the middle school, okay? So take our 192.168.0.0, and the first thing we need to do is start carving this up, okay? We can take from 0 to 127 host range, which would be designated as a /25, okay? That's going to carve out part of our address space. That address space is going to be assigned to our middle school. We now have our middle school covered. We still have a lot of address space left over, okay? We can take the 128 to 191, and we can allocate part of our existing space out here to our elementary schools. This is what causes us to be doing VLSM, okay? We're using variable length subnets. We don't have to deal with the entire 254 address space all at one time. We can carve it up into more manageable units, okay? We've allocated our elementary schools. Now, I know we want to forget our administrators, but we'll put them in anyway. And again, we can subnet further and allocate another part of our address space to our administrative hosts. We have a little extra space left over here, which is good. We always want to leave a little bit of room for expansion. Then we have our 6 interlinks, okay? When I go to work my interlinks, I work backwards. It's the way I like to do things. It's the way I like to teach. I put all my routers and my switches up in my highest address space and work down. My hosts, I work from the bottom up. My equipment, I work from the top down. And we can use our /30s to fill in all of our required interlinks, okay? We have plenty of room left over that we can get things done. Now, we've looked at the VLSM. We've worked the bits in order to get our subnet masks, and we've allocated our space. We don't have the job done yet. We still need to deal with our high school, okay? Our high school requires 250 hosts out there. So, we add a whole nother space. And it's the entire 192.168.1 network. This will give us enough space that we can go in and we can allocate all of our 250 hosts with a standard Class C/24. So far we've been working straight subnetting, variable length subnetting. Where does CIDR play into this? Okay? We'll go back and we'll look at the bits again. This was our starting space, 192.168.0.0. This was our added in space, 192.168.1.0. We now have our entire corporation represented. But when we go to the outside world, that's an awful lot of entries into your tables. We want to go through and we want to use the CIDR or supernetting in order to represent this entire thing as one address space. So, we can ignore the high octets, they're identical. We can ignore the low octet, that's variable. This is our octet of note, okay? We go through and we start matching bits. Every place we have identical bits, we leave it as is. At this point right here, our bits start to differ. From here on out, everything belongs to the school. This becomes our address space, okay? Host space, address space, we can go through. But even though it looks like we started with our same network, because we had to come into our 23rd bit, we set it as a supernet. This one network address space represents everything that we've allocated up here, okay? By just following the bits and looking for all like bits, where the like bits stop is where we have to stop also. We can count the bits up, find out what our subnet mask is supposed to be, and we've done our supernetting. This is the value that CIDR gives to us. Even though we like to work with Class C networks, sometimes our applications do not allow us to deal just with Class Cs. We can start grouping Class Cs together and put them into our CIDR supernets. Thank you for your attention.